we want to be the propulsion provider for the next generation of European launchers. So as simple and as ambitious as it might sound, we want to become this Rolls Royce of space. I put actually all my savings, like all of them. I remember always that the first 50K check, we believed that we were like reach. Like, wow, now we can do so many things with this. And then you realize, oh, it's absolutely not even peanuts.
Space is humanity's greatest laboratory. Defense is democracy's strongest shield. And today, in workshops, in laboratories, in startups, a new generation rises, not to observe history, but to write it, where every innovation above drives progress below, where every breakthrough in defense preserves our freedom to create. Behind every breakthrough stands a founder with a story. Now these stories emerge to light the path for those who follow. Welcome to Rockets and Radars.
Hey, Adrià, grab your drink. So in the case, it's coffee in a Star Wars cup, which is good.
Yes.
In my 0.5 liter coffee, we are caffeinated. And let's all get comfortable. You went from being an aerospace engineer with a theoretical fascination to building a company that made the 70-year-old AeroSpike engine concept a reality. And later, you secured 23 million euros in Series A, which was actually done a few days ago. So I'm very curious to deep dive into that. So apart from this fascinating journey I want to tap on, I also want to understand the person behind this journey, the highs, the lows, and everything in between. This is going to be hopefully the best biography of you and Pangea Aerospace. So let's get into that. So before we get into the very beginning of the journey, in one sentence, what is Pangea Aerospace for people that might know you yet?
Before that, of course, thank you, Martin, for having me here. I'm pretty excited. And what is Pangea Aerospace in one sentence is the advanced propulsion provider for the future of space industry. Simple and as complex as
it looks
sound.
That you worked on the pitch for a long time, which is good because the best pitches are after thousands of iterations. Okay, and on the personal side, who is Adrià when he's not building rocket engines?
Okay, so I'm a geek fan of engineering in general, but mostly I would say motorbikes. I'm a huge off-road biker. I raced motocross since I am, I don't know, like 16. And every weekend I need my dose of burning gas and jumping. And yeah, it's my moment to evade and thinking only on doing sports, being in the nature and some speed.
Let's get into the very beginning of the journey. So your background includes work at Avio and AI system. Walk us through your journey before Pangea, before anything happened.
Absolutely. So as I said, I'm an aerospace engineer. I started studying in Spain mechanical engineering. That I did a double degree with aerospace in France, in Toulouse. Started working there at Airbus. I would say like 70% of people in Toulouse work at Airbus, so it's nothing rare there. Working in propulsion. I was an engine performance engineer there for the A320neo, so the most common airplane that is flying European air. And then the thing is, I always wanted to pursue something in propulsion, aeronautical, or in general. I always kept myself informed in the articles being written on aeronautical, like turbofans, rocket engines. But of course, rocket engines is, the supreme thing, like in the sense that the most challenging part of it, because it has to withstand extreme temperature pressures.
It's a rocket science.
Yeah, it's rocket science, literally. And even though the main principles of working over rocket engines are super simple, it's just burning stuff and expel it through a nozzle. It really was super interesting to me how that very simple equation could transform in so many pain in the asses and complications down the road. So that is why I decided to, after some years at Airbus, to come back to my propulsion geekness and like inspiration and start looking more into the rocket or space propulsions. And then I decided to quit Airbus. I decided to going again on study in Rome, where I did a master on space transportation
Oh,
systems development, where actually I met my part of my co-founding team there, and working at Avio there on the Methalogs upper stage of Vega. And then at the knowledge of that, I was pretty clear that I wanted to do it something on my own. And I jumped into the pool. There's a Spanish say on this, saltar a la piscina, when you try something even not knowing if there is water actually on the pool.
hmm.
And
Did
yeah,
you always know you would start something by your own?
I knew it. I always have been um, very curious, tirelessly curious on this, and willing to be my own boss and
Oh,
try to convince people and lead people towards a same goal. Of course, when I started my career at Airbus, I didn't know that, because you start, you're super junior. It's like whatever. It's working on the aerospace sector. That's cool. Then later on, being the experience on being in a big company gives you a sense of scale. That, of course, when I entered, the impact that I could have was pretty limited. So that's why I decided, okay, maybe if I try to do it on my own, there will be a lot of highs and lows, but at least it will be something that fully aligns with what I want to do and who I want to become.
if there are similar engineers at this specific stage, they are thinking about something, they don't feel they have an impact, what would be your message to them?
If you have a need inside of you, just go check it out. It
Mm.
potentially may end in nothing. Actually, you have to know yourself deeply in order to don't frustrate you a lot, because there will be frustration. It's part of the path. But at least to try it. If something that keeps you awake at night, that means that it's something that you really start to look more in depth. So try it.
Awesome. I hope this whole conversation will actually spark new talents and new companies created in the near
Sure.
future. So let's hope
Yeah,
for that. Okay,
definitely.
cool. Let's get into finding your co-founder. So you said you met some of them at the university,
Yeah,
which was in Italy, right?
Italian. Yeah.
Yeah.
So after working at Airbus, I decided to do this master's in La Sapienza in Rome, to have some ideas, but I knew that building whatever you want to build alone is impossible. I needed passengers on the trip. And then there, I've made quite good friends. And I actually talked about it to three of them that then become the co-founder, the other three aerospace engineers. And I always explain is I had my own serendipity moment, because as I said, I was already a fan of AeroSpikes, looking on all the engines that NASA, Aerojet Rocketdyne did in the past, and of course, amazed by the marvels of engineering that these guys did. Funny enough, one of my co-founders, Federico, our head of propulsion today at Pangea, just before doing this master and meeting me, he had just finished his thesis. You know on what? On our spike engines,
Hmm.
out of the blue. Like that was our serendipity moment. It's like, okay, so I'm coming to do all of this because I have something in mind with our spike. So it's very good that we have to be in the same place in the same moment. And then we start talking on this, and then 7 years later, we've created a company, and we've actually developed and fired an AeroSpike engine.
Can you give us a bit of a context, especially for people that haven't ever heard about AeroSpike engines? What is the
Yeah.
history and why are they so cool and why they're the future?
Okay. So an AeroSpike engine is just a type of rocket engine that is more efficient, because it has the capacity to adapt to the ambient pressure. What does this mean? A rocket engine normally is designed to work at sea level. When you see a rocket going up, the first engines, the big thrust engines that we see on first stages, they are designed to work only at sea level. And then later on upper stages, you have another engine, normally a vacuum optimized engine, that it only works perfectly at optimally in vacuum. There's no engine that actually works well throughout the whole trajectory. So you have to be very good at designing engines for two specific moments, sea level and vacuum. The AeroSpikes, just thanks by its geometry, have the ability to adapt. It doesn't care whether it's in sea level, in the vacuum of space, in Mars, whatever. You can always expand the gases freely, and then this gives you an extra efficiency of around 15 to 25%. It depends of the configuration. And you might say, yeah, but hey, 15 to 20%, it's not, this 10x, 100x that many deep tech people would look for, especially investors. But actually, when you talk to rocket scientists, they say, yeah, I mean, Avio, for example, millions and millions of euros or dollars were spent to increase half a percentage the performance. So if you can actually convince and showcase to everyone, like, hey, I have something that it's already giving you 15, 20% more efficiency. And actually, since the rocket equation, unfortunately, is not linear, it can actually translate into 30, 40% more payload. And 30% more payload is 30% more revenues for launch providers. So, and of course, when you start talking about money is when everyone starts caring.
And in space, every gram counts, right? So
yeah,
this
exactly.
is huge difference.
So
Okay.
this is the economical, but if historically, to actually complete the answer to your question, why we unfortunately have not seen any AeroSpike flying is because they are hard as hell to build. So in history, there has been at least two projects that, of course, we've looked extensively into them. The first one was during the Apollo times, so the Saturn V rocket. So the first engineers at NASA wanted to even increase the payload capability of Saturn V to get even more payload, more people, more mass to the moon.
So we are talking about 1950s, right?
60s, yeah, 60s, okay. Late 60s, 70s. And they actually started developing an AeroSpike called the J2C that actually was supposed to replace stage 3 and 4 or 2 and 3 of Saturn V. It was an Hydrolux AeroSpike, of course, with the budget of NASA at that time that they didn't care about the cost. It's like, we need to go to the moon. And they actually developed one. They fire it. You can check it out on Google. There's quite a lot of very interesting images. Then, unfortunately, the whole Apollo and Saturn V program got canceled. So no more flights. I think they ended going to the moon in like 75 or something like this. And then out. So quite a lot of AeroSpikes there just hanging, not flying. Then we have to flash forward, I would say, 2 decades. So by late 90s, with the Venture Star program, and that was this after the space shuttle was not as reusable as many people would have loved. They had this program of building an SSTO, a single stage to orbit rocket that actually Lockheed Martin was leading and priming. The vehicle, I think, was called the Venture Star. And it was an Hydrolux single stage to orbit. And if you have a single stage to orbit, so if you want to maximize the efficiency of your engine, of course, an AeroSpike is the engine to go for because you just develop one engine and you have it through all the trajectory. Problem there, it was a linear AeroSpike, it was Hydrolux, and they had a lot of issues, not on the engine though, because they've even tested. I actually invite everyone to check on this engine as well. They had a lot of issues on the tanks, cryogenic tanks and composite with hydrogen. And once again, I think they decided to just cancel the whole program. And another beautiful, in this case, linear AeroSpike that was tested on ground but never flew. Later on, we have Firefly Aerospace that on the early days wanted to do an AeroSpike too. However, they wanted to do not a turbo machine fed engine, but kind of a pressure fed. And I would say that they've decided some early decision from the system perspective, from a propulsion point of view, that we at Pangea do not share. And then they say, oh, this is too complex. We have to add so many different things in order just to gain not a lot on the engine. Let's go back to a classical engine. So many have tried, even built some engines, but unfortunately that never flown. And this is historically because as well, the problems itself, the technical challenges are the manufacturability of aerospikes is complex. And they're large. And this actually imposes you the thermal management actually clash because you have a lot of surface to cool down. So you have to master all the thermal management, the cooling uh, technology that you have to impose. And in our case, one of the things that we've done in order to make it viable economically is like, okay, how do we can make it cheap? And here, additive manufacturing or 3D printing has a big say because 3D printing allows you to do almost magic and it gives you a freedom of topology of design that it's amazing if you know how to master it. And then uh, even with that, we said, okay, we can do almost any cooling channel that we would want, but still we need quite a lot of fluid to cool it down. What if we utilize both propellants to cool it down? Because as well, from a purely technical point of view, a rocket engine is, I would say, the majority of the times cooled down by the fuel. So it's a kerosene engine, it's kerosene that cools it down, hydrogen or methane. But you have as well in your rocket quite a lot of liquid oxygen that is it's, liquid. You can actually utilize that fluid to cool down. Of course, oxygen, you have to be careful because otherwise it can kaboom quite easily. But if you maintain it under certain margins, it's still quite a lot of fluid that you have there. And we actually implemented this in all of our designs, and we're utilizing both propellants in order to overcool mainly our engines and then have them work better through a longer life cycles because we are designing for reusability in mind as well.
You just mentioned a lot of
Yeah.
technical challenges that are connected to actually creating a working AeroSpike engine. So what made you confident you could succeed where others like Firefly or Lockheed, they hadn't? Like what made you like say, we will do this no matter what?
Yeah, in this case, let me then go back and explain you a little bit more of the history of the first AeroSpike we did. That it's called Demo P1. We were pretty bad at naming. I always say the same demonstrator for propulsion one. So this is a rocket engine that it's an AeroSpike engine only in two parts. That it's 2 tons in thrust, so quite a lot already for a first cryogenic engine, and utilizes methane and liquid oxygen. So why we decided to go through this path and demonstrate to ourselves first, and then to the rest of the world that we're capable of that is first we were, and we still are, startup or little company that really can risk way more than Ariane Group or Firefly Now or NASA or whoever. So you can just try and try to make it work as fast as possible. Because if we go to tackle all the specificities of these engines, so it was fully 3D printed. So we tested this engine in 2021. When we start contacting 3D printing companies, not even the material that we wanted to do it was available. And it changed in the framework of like 1 year when we started to actually fire, because from design to test, we did it in 18 months, a year and a half, which is crazy in rocket engine standards. So it was 3D printing. So people were like, you're crazy. This is going to fail for sure. It was a new material actually developed by NASA that we had access to called GR-COP42, so a copper-based alloy. It was only 2 pieces, and it was an AeroSpike. So you see, it was everything not in the good spot because people like, no, the traditionalists, oh, this is not the way you do it. You don't 3D print, you don't do AeroSpikes. But we were naive enough and blunt enough, I would say, to actually go that path. And we demonstrated that it was possible, that 3D printing actually works if you more or less know how to do it, that the AeroSpike actually worked. And in this case, our cooling methods of having 2 propellants worked. And actually, there's a fun story on this. The last day of testing of that engine, we were tested in DLR in Germany, German Space Agency, and we wanted to melt it. We said, "Fuck it." It ignited on the first try. I mean, we're more than excited and more than happy with what it has done and all the data we've had. Let's blow it up. And actually, we forced the shit out of it, like forcing with throttling down, throttling up, forcing having what it's called dual phase in the cooling channel. So you don't have a full liquid, but you have liquid and some bubbles of gas, so which is something pretty bad for the cooling capabilities. And it withstood everything. So literally, we run out of propellants that day. And I remember telling to the guys and the engineers in the DLR, like, we failed. We wanted to actually melt it down and we failed. So all the design, all the efforts, all the margins, all the blunt decisions we took actually paid off. And now we can lower the margins here. So it was a huge achievement, but I would say even more a huge learning from all of us. That,
How did
hey,
you
this
get
is,
access
yeah.
to the NASA material? Because that's a crucial part of the design,
Yeah.
right?
Because through our partner in 3D printing, we actually convince them that we have a very, I would say, sexy use case for an AeroSpike, and this is why we got the license. And yeah, we still are using that material. That it's now commonly available through Europe and through the entire world. But
Simple
yeah,
but
it was,
works.
yeah,
Okay,
yeah.
super. Let's talk about the business and economic viability. So initially, in the very beginning, what was your initial business plan? Were you always focused on only propulsion systems as you are now,
No,
or have you? Yeah, okay, let's get into that.
not at all. When we started the company, that is true that the R-Spike, so the differentiator in propulsion was always there. However, we started willing to be a micro launcher company,
Mm.
another launch service provider, with reusability in mind and with this type of rocket engine that is different and would give us extra performance. But then we've developed this demo P1 that we were just discussing about. We even primed a grant from the European Commission to test a recovery system that we patented and unfortunately didn't scale up well, and that we ditched it. But then we make a reflection, a hard reflection, as a entrepreneur, as a founder, is something that sometimes you tend to lie to yourself. No, it's gonna work, and you advance. At some point, you have to. I remember, like, you stop. Let's sit together and make what makes sense. Do we see a path forward with being a micro launcher? Yes or no? And then we decided to actually stop there because, being profitable on the micro launcher segment, it's not impossible. There's people actually doing it, but it's very, very, very hard. And you have to excel at so many different things. And actually, to these days, we are seeing like ISAR that is about to launch, RFA, everyone. So we would have be in that race. But we believe that the geopolitical situation in Europe and everything was better to concentrate on something to help the winners of the micro launcher to scale up. Because one of the things that we're seeing, and we actually predict some years when we pivoted, is that, as I was saying, the economical viability of the micro launches is complex. So the majority of them are thinking, oh, I would need a bigger rocket.
Mm.
And if I need a big rocket, I need shit ton more money to actually build it. If I go to the investors and ask, like, "Hi, could you give me 1 billion to develop the Falcon 9, whatever, or the Neutron replica in Europe," it's complex, the investment ecosystem here. So if we can divide that need and chunk it and say, hey, the industry is maturing. There's one guy, and there's some guys at Pangea, they're only developing engines. So I would need way less money to actually develop this and could start buying engines from them. I mean, it's the case for propulsion, but we're seeing more and more companies focusing, I don't know, on the avionics, master, or some others mastering the tanks, even the launch pads, like, mobile launch pads and whatnot. So we said, okay, let's help them and be there, have products ready for when this will come. And we're seeing that it's actually paid off. And we don't have conflict of interest. That's another big thing that we thought. So if we've seen in actually in the industry, for example, Blue Origin and ULA, that they agreed on selling the engines, but one is a competitor of the other. So at some point, the one designing the engine could say, you know what? You're picking my customers, so now I increase the price of the engines 2x, or I just decide to close the tap. So for us, is no, I have the full interest in developing very good engines and to work for everyone, and they can really concentrate and focus on the core business of a launch service provider, which is
Mm.
not designing a rocket A, B, or C, nor the engines. It's actually providing a service to a customer, being a satellite, humans, whatever. And yeah,
And I guess that's the reason why I pivoted, right? Because when we were talking about AeroSpike engines, that's a challenge that nobody has ever
yeah,
solved like
yeah,
successfully, right? So it's challenging, and launchers are also challenging.
absolutely.
But there are no AeroSpikes globally right
Yeah,
now, apart from you, right?
yeah.
But there are a lot of micro launchers. So I'm trying to figure that out. Like, what was the thing that made you to pivot at this period?
Yeah, the thing is this is concentration on propulsion systems
Mm,
and even going beyond the AeroSpike. Of course, the AeroSpike that we're working now on our product that is named Arcos, which is quite a big AeroSpike for upper stage applications. We're seeing that it's much more performing than the classical upper stage engine that could be compared. Uh, but then it potentially will enable later on reusability of upper stages because we're seeing that
mm.
reusability is kind of a big thing. And you can use actually the engine, the AeroSpike itself, as a heat shield on your way backward. And this is, of course, something that we're working on. It's not our main goal because our main goal is first it has to go up before coming down.
I like the focus.
Um, yeah, and but then later on, we are seeing that reusability is here to stay in general. Unfortunately, in Europe, and I'm talking, of course, with my pro-European hat, we're late. We're way, way, way late. But we have to start building the critical technology bricks that will allow in the near future, in the midterm, to becoming this reusability as a almost as a commodity. If you plug one Pangea engine, hey, your stage become reusable like this. That's of course the idea. Is way easier said than done, but that's the idea. And not only focus on aerospace because we're seeing that not everyone when you say, hey, I have this that I'm building, is like, yeah, but I don't need that. It's too big or it's too small. Would you do as well? I don't know, in space propulsion system? Would you do actually very large engines? And we decided to be as much transversal as possible because all the technology challenges that I was explaining before for this first engine, we had to excel at, additive manufacturing, at
Mm,
designing and software modeling on how to quickly have preliminary designs of engines, on the manufacturing techniques, on having our own test facilities. So all of this actually was transversal. So it was used for the AeroSpike engine, but now, then later on, we decide, okay, we see a lot of potential on the in-space mobility market. Let's focus on some green propellants as well and working there with, 1 to 200 Newton scale thrusters and propulsion systems for OTVs, racks for launchers, even landers, etc. And we're doing that as well. And then on the other extreme, working on very high thrust engines as well that we actually recently won a contract with ESA that we're developing Europe's first full flow stage combustion. That, of course, we're just on the beginning, but we can concentrate on this because it's propulsion and we are only having every euro that we raise that we want contracts is just to the propulsion. And this focus allows us to cover the full value chain of propulsion.
Cool. I really like the way how you're thinking. Thanks for sharing your thoughts here. Okay, let's talk about funding. So, in the very beginning, how did you survive? Where did you get the money before you get into the seed round in 21?
So it was the classical story of the triple F, the family, friends, and fools. So when we started the company, all the founders put something. I put actually all my savings, like
Mm,
all of them,
all in.
uh, all in. Yes. And then I remember convincing the first business angels when you got here. I remember always that the first 50K check, we believed that we were like reach. Like, wow, now we can do so many things with this. And then you realize, oh, it's absolutely not even peanuts. It's the peel of the peanut. But it was a lot of this. Then we did some crowdfunding as well, that we raised first million with this, and then went to the seed round. But we take it quite a lot via steps, raising the money to develop the first demonstrator and the recovery technology that I mentioned that unfortunately failed. Then we did the switch and started raising more money. However, the Series A that we just closed was pretty complex. It's always, I'm guessing, all the founders, all the people you're interviewing kind of says and shares the same. Fundraising is complex. You know when you start and when you need the money, and you never know when you will actually end it up and close it. So we wanted to raise the Series A way earlier. Then it came, post-COVID nonsense, the space bubble as well for the
Mm,
classical, the SPACs and all this. And we forced ourselves, let's go commercial, and really trying to understand, talking to potential clients, talking to launchers. Hey, what are you looking for into an engine? Do you care about performance, or do you care more about the price or the availability? Grasping all of this in order to tackle it, and not only on the launcher side as well on the in space. And because of this, we started going commercial, winning more and more contracts, mainly on the institutional side. And actually, that was the necessary, I would say, pipeline that actually convinced our investors now for Series A that it was
mm.
rare on founding a new space company having revenues and revenues by contracts, no grants, and this actually was good. So the potential that we have is what really convinced them that we've passed our lows, and we were really close to almost close the company, but then winning one contract, then another one, and then little by little, and finally making through Series A. So actually, from not raising the funds, we've learned the very hard way, that is true, but we've learned that how important is the commercial aspect. And I'm saying this as an engineer myself, because even when I fund a company, hey, that's super cool, let's build engines, da, da, da. But then if you build something that nobody cares about or nobody wants to pay money for it, what's the purpose? If you want to do this, go do research, which is good as well, but it's not what we are aiming for. So we are here
Awesome.
to, yeah.
True. Okay, we'll get into Series A more in depth. I would love to ask some very specific questions there. But before we
Mhm.
get there, I would love to cover the whole fundraising journey. Let's get into the learnings that you got, how the pitch evolved over time, and when we get to the very beginning, when you get the friends, close and family, and then angels, then you get into the seed round in
Mhm.
May 2021. So I'm very
Mhm.
curious if you have any thoughts there on any learnings or any memories that you would love to share with the community, something that could be very
Sure.
useful.
Um, yeah, when we raised our seed round, we were still on the uh, rocket, let's say, idea. And I mean, it's so easy now to think back, but I would say how naive we were. And do you think that things, hey, if I raise this, then everything will go as planned, and then when going to the next milestone? So I would say that even us, but also the ecosystem, we're still in the formation for the new space. But even though, of course, now I would do things, some things differently, it's just recreation the pitch and how do you explain to people how much time you spend on simplifying it. Because of course, if you talk to, in our case, a rocket engineer or a rocket engine engineer, we could go talk details and something super specific. But this is normally what investors do not want to hear because they give it as a done thing. If you're already raising money, this is, yeah, you will solve this. Tell me about the scalability of it. Tell me about which problem are you solving for whom. So the pitch has evolved, of course, in order to, and I'm working very good with the amazing team that I have on actually repeating and really asking ourselves the difficult questions. And I remember being in so many calls with investors, being asked things like, "Oh shit, I don't know what to say now."
How did you
Really?
approach those moments where you had like, oh no, I haven't considered this question yet?
I mean, the best is like, hey, let me think about it and
Oh
get
yeah.
back to you with an answer. But actually,
Okay.
I kind of like those questions, of course, even though it's kind of exercise of like, oh, I thought I was super prepared, but no, I learned something today, and I will have to work harder for the next one. But yeah, I approach it like, okay, or I don't know this, and let me go back to you with that
Do
on the
you remember
scalability.
the Do you remember the most challenging question you have got that you had no idea, but it's super important?
Not one specific question, but I remember a couple of investors that were super picky. And meaning
Hmm.
picky, I'm not saying in a bad way, in the sense that on the first call, they asked me very specific questions of almost, cells of our business plan Excel. And at that time, I was like, I don't know, let's deep dive to it. And you have, even of those moments, you have to be ready to be quick and answer. And yeah, let's dive into it. And sometimes you feel like scared of attack, like, oh, I don't know this.
Hmm.
And I really, are you willing to go to this level of detail? And I just met you from like 20 minutes ago, but you have to be ready. So I would say that it's like a trained athlete. You have to be ready to deliver and score that goal in minute 90 of the game. I'm a quick and good football fan, as you can say.
By the way, what was the biggest difference between Seed and Series A? You raised Series A very recently, so
Yeah.
I'm curious if you have any thoughts there.
Yeah. Mainly for the seed, you still are pursuing an idea and a technology. The big difference from seed to Series A is that the technology has been demonstrated, validated, and not only technically, but as well from a credibility point of view, even institutionally, because we are backed up by institutions having contract with European Space Agency, French Space Agency, Spanish Space Agency. So I would say now it's more on the scale up thing and the potential we have that, hey, if we do this right and we identify this product that would solve this need, this other product, this other need, now it's more on the scalability and potential for sure.
Okay, awesome. Throughout the whole journey, you had both private and public financing, let's call them public investors like
Yeah,
CDTI on board.
correct.
How important was the mix of private and public? And if we can tap into them, what are the biggest differences and what would be your biggest learnings on talking with each of those?
I would say that in Europe, everyone that has a VC inside in their cap table, indirectly they're having as well a public institution, because you know that many VCs, they are funded by public money, so the EIF, for example. So talking about purely government or purely private to me is not a reality, because you will have both. Having, in our case, CDTI, so the Spanish government, gives us credibility. Whenever I'm going to talk to potential customers, it's like, hey, I'm backed up by my government. So what is above that? I mean,
Good
there's
credibility
nothing
for sure.
for the credibility. Then, of course, they don't have potentially the same ideas of a purely private fund that needs, their ROI in 10 years, and I need to leave and have an exit by year X. So the good things about the public is they are passive capital. Uh, but on the other side, having private guys, of course, gives you this sense of urgency. And we have it too. I mean, I don't want to start sleeping on my own, like, oh, yeah, don't worry, we have these guys supporting us,
Hmm.
so it's covered. No, we have to deliver. So having both, I would say, is a need and a reality that even though you cannot avoid.
And I think each private and public players, they have different requirements and they let you to think
Mm-hmm.
about things differently, right? So I've seen some founders looking only in public in the beginning or only at private, and both of them they burned their bridges a bit because they said, "Oh no, we are not gonna go public because it takes a long time. No, we are not gonna go private because they will ask hard questions." So I love
Yeah.
how you approach this mix of thinking about both and considering them. I
Yeah.
really like that.
Yeah,
Awesome.
absolutely. Yeah.
Let's talk about contracts. Do you remember how did you get your very first contract, and who was the one that gave them to you?
One of the first contracts we got was with ESA. Once again, having ESA as your client is good. It forces you to be good. And whatever you were saying before was bullshit, because now you have to deliver in front of somebody, and that's the very good learning curve. Like, okay, as I was saying, go talk to your potential client is one thing, understanding the market is another thing, but then having a contract agreement that, hey, you have to deliver this. Really, it's an upscale for sure. And yeah, I remember doing a pretty good proposal, then negotiating with them was also a pretty interesting learning thing. Um, and then for me, the best moment on this was not only winning the contract, but I started working in this case for a specific topic of engineering, propulsion engineering, together with European Space Agency colleagues. That was quite a lot of transmission of information, learning from them, and them learning on the bluntness, on the risks we can take as a startup or data company. And this is actually something that goes beyond, I would say, this contract or in general, and it's more kind of a general thought that I want to share, is that new space in general, sometime until now, many people is like, oh, I'm new space guy, so I don't want to talk to the
Mm.
old guys, or the white hair, or this. And actually, no, we have to embrace that. New space is here to demonstrate in some areas commercial viability of some space products. We can take much more risk than the legacy players because we're just smaller, as simple as that. But we have to learn from those guys because those guys have done it. So for me, it's not valid. No, hey, I'm new space. I only want to be with young engineers. No, you need the seniority as well. And this is something that still sometimes I'm seeing that, or the other way around, like legacy players, no, I don't want to touch, innovation or new stuff because the way it's done is like this, A, B, and C. So finding this delicate dance on how to attract seniority, how to combine it with younger teams and learn from what has been done before. It's something that we try to force ourselves in every contract we're doing with institutions or even in our hirings, of course.
If you went back to the past and you would meet the younger self, what would you
Mhm.
sell to yourself how to get the contracts from institutions and legacy players faster?
Ooh, in the case of space industry that it's so politically intertwined, to go way earlier to talk to your national agency, because they are the first one that would have to pitch your company in front of ESA, uh, and be more blunt in the sense, hey, I have this, I want to fund it like this. Prepare yourself a project, not wait the institutions to open tenders that some of them will match with things that you're having. So going there, present what you're developing, and hey, this is in this case a need or an opportunity for Europe. Do you want to buck it up? And then if you have the support from the institutions, or as I was saying before, on the public investors, then private investors are seeing that as another opportunity, because the first euros, the first contracts are already given, so their investment is in some sort the risk.
Again, very interesting approach, proactive rather than reactive to what opportunities and tender calls are available.
Yeah,
Love that. Okay,
yeah.
we will stay on the topic of contracts, and I want to get into the
Hmm.
commercial ones. So,
Yeah.
can you tell us more about how did you get your first commercial contracts?
The commercial contracts came later, for sure. Unfortunately, I cannot share the names of our clients. But once again, is people that are seeing what we are developing, and are seeing that once again the positioning of Pangea is pretty important on this conflict of interest that we were mentioning before. That we had the technical credibility and the technical expertise, not because whenever we are showing what we're developing, we know how to defend our arguments and we have a plan for everything, but it's also that this public contracts, institutional contracts for development contracts that we have, that is backing up on this. So I'm building something that will be done, so it will be there for you as a private client. So you take it, and people are even willing to pay already for that, for these early development contracts. So I would say it's a combination. It's a weird ecosystem, the space industry, that you cannot go fully private or you cannot go fully governmental, to my point of view. So it's a combination of, if I convince one, I will have more points to convince the private customers, and vice versa. Because then whenever you go into to institutions saying, I have this as private clients, so if you gave me a contract for this, I think it could scale up faster, and this is interesting for the full European ecosystem that is at risk, unfortunately, on these days.
What would you think is the biggest difference between getting a public and a commercial contract? What is the thing that you really need to think about when talking with commercial that you wouldn't think by getting a public contract?
I would say for commercial, of course, it's speed. Speed. You have to be fast whenever an opportunity arises. Be as much serious as you can be. I mean, serious by the sense of delivering a good proposal early on, and of course, then you would be able to cut the corners. But I've been one of the learnings that I've had so far is that taking fast decisions is better, is paying off later on, rather than waiting to have a better proposal, or that thing we could still improve it to X%. No, it's good enough. Send it, try it, see, iterate with the customer if it's good or bad. And actually, for the institutionals, no, the institutionals in our case are more interested not in the speed, rather on in our case, the technology building blocks that would have potential spin-offs outside of the space ecosystem, but also what are the technology building blocks that we're developing for Europe in general. So it's a matter of a strategic, and the other is, of course, a speed and the availability of a product.
Great answer. Okay, let's get into the product portfolio. It is something super important as you are creating products, right? Let's explain to the whole audience what is your product line over the time in your top line. You started with demo P1, then you mentioned that you pivoted into propulsion only. So what happened right after that?
Yeah. So we have our commercial AeroSpike engine that we're developing, and that we've mentioned during this discussion, that it's named Arcos. It's a 75-ton Metalox AeroSpike engine, mainly for upper stage applications, for medium launch vehicles, that can be used as well for first stages of micro launchers. So it is good, as I was saying, it's just one engine that can work both on vacuum and both on sea level. So this is, I would say, the gem of our portfolio is mainly the focus of the use of proceeds of our Series A will be on there. Then if we go to the in-space mobility, we are having a line of products called Unix, that it's storable propellant propulsion systems based on green propellants, in our case, HTP, so high test peroxide. And we're developing their solutions on the monopropellant side, but also on the bipropellant side for racks of launchers, for satellites, for OTVs. And here the range we have from 1 Newton to 200 Newtons. And the first one we're developing is a 20 Newton that we have a launching customer that is for capsules. And then, so in space mobility, AeroSpike engines. On the big engines, we are developing what we call Kronos, which is this 2.5 meganewton full flow stage combustion engine that we won the contract for the European Space Agency to, build the whole development plan for it. We're even doing our first printings of very, very large combustion chambers in order to see how our manufacturing technology scales up. And hopefully becoming that propulsion provider for Europe if Europe decides to have, I would say, the Starship-like, the European Starship-like launcher coming on.
When you started through the pivot to Arcos, right? Your main thought in your head was, we need to focus. We need to focus on propulsion only, and this is what we are the best at. Right now, you have more solutions within your product line. So I'm very curious, how do you think about adding another solution into your portfolio or not adding towards having a bigger focus?
Let's start by the end. On this the latest I was explaining, Kronos is a super large engine that we are just at the start of the journey. It wasn't, to be honest, it was just an opportunistic thing here. We saw that in this case, ESA was very interested in a company or someone that would tackle that critical building block for the future. And we said, okay, we're only focusing on propulsion. We are developing all the expertises, the shared IP for all of this. We could tackle this. And once again, we will not be on any conflict of interest, because I would have the interest of selling it to as many players as possible. And ESA actually was super interested on this and not repeating some of the previous errors or developments that were actually on this. And then on people having this conflict of interest, are not willing to sell engines to their potential competitors. So on this case, it was opportunistic, and we are just at the beginning. When we were focusing on Arcos, and we decided to start as well investing and investigating as well on the in-space, it was because it was earlier in time that we could have a product flying. And the saying in the space sector, until you fly, you lie. So you need to have something in space. And even though we might go slightly slower because we are having 2 parallel developments, there's still 2 propulsion developments. So there are a lot of commonalities. Actually, even the whole organization inside Pangea is done to work as much as a matrix as possible and not having silos of information. And we thought, okay, it can be a very interesting revenue lines for our portfolio and for our future investors, that they will say, hey, I'm developing engines for everything and everyone that wants to go to space and actually coming back from space later on. So it was, I would say, fueling the vision, having this thing of the in-space, and it's a revenue line that was worth investigating. And hopefully by the end of this year, as I was saying, we'll have something already flying.
Before we get into the vision, I want to hear your thoughts there also. I'm curious, if we get back into the Series A round that you just raised recently, which products have you been actually considering within this pitch? Because you had already potential product line, right? So
Yeah,
what was your strategy in this? I actually saw the deck, and I think you were doubling down on Arcos mostly, right?
yeah,
But
yeah.
for people that haven't seen it, I'm curious to share thoughts here.
Yeah. So for Series A, it was focusing mainly on having this first Arcos engine integrated and be ready to be tested first on ground, of course, and then later on orbit demonstration mission. Um, and also the scale up of production for the Unix system for the in space. So now we're building the first prototypes. We are actually finishing integration of the full system and being able to integrate it with our customer and fly, as I said, by the end of this year. So the
Awesome.
idea was this: focus on these two products. As I said, of course, some focusing as well on institutional projects and contracts for Kronos. That we have some news that we will share soon that I unfortunately cannot yet say. But this is just building up midterm to long term. So now Series A is A. I need to have Arcos ready to fly and in space thruster flying to simplify it quite a lot and summarize it quite a lot.
No, thanks for making this simple, so a lot of people
Yeah.
can understand this. Okay, one last thing around the Series A. So when we first tapped into that, you mentioned that it was harder than you thought. So
Yeah.
if we do this exercise, that if you went back and see your younger self, what would you tell yourself regarding raising Series A?
Um, of course, I'm biased by my own experience, but I would say the fact of early on talk to clients, to customers, what are their needs, what are this, and really tackling directly to investors. Hey, I'm doing this engine because Mr. and Mrs. A, B, C, D, and E had told me that they did this because they cannot fund it themselves, they don't know how to do it, etc. So I would say the product market fit, which is a cliche, but it's true. I
It
mean,
is a thing.
it's a cliche for something as well, for a reason. So I would say, yeah, focusing on this, and then learn on how to sense people early. There's in the sense, as I was explaining, sense the picky ones, and if they want to be picky, you have to be picky as well. And if they are only interested in the vision you have, like sharing boldly enough and in 1, 2 sentence, hey, I want to become this, the space sector, so they can really get addicted and actually impressed by the team and this. I would say this. The technology is important, of course, but more is the commercial push and who is with you, the team you're putting together to actually do it. Do they have actually the capacity to take hard decisions, to say no many times until they find a yes? So this, I would say, product market fit and team. Yeah.
Awesome. And team-wise, what is the
Yeah.
strategy in hiring? What were your first
Oh,
hires and how were you think about it? And has your strategy changed over the time?
hiring is something that I particularly like a lot and I like to get involved because I think it's critical for the company. But it's hard, man. It's hard. It's hard finding the right skill sets and with the right culture fit. It's complex. One thing that when we created the company, actually, even it's in our name. So Pangea stands for this all Greek. I mean,
Mm.
all and Gaia means Earth. So all Earth together is because from the 6 founders that we are, which is quite a big founding team, we are 3 Spaniards, 2 Italians, 1 Swedish. So we're coming from different backgrounds, different culture, even within the continental Europe. But we wanted to really have this super intertwined within us and within the culture that we are developing at Pangea. So for us, diversity is important, respecting tolerance is important, and we want actually diversity in the sense I think we have 17 or 18 nationalities in the team. We're looking for even more because this is it gives opens your mind on how things have been done or have been the rationale behind all of this. And this is something that it's hard to implement. And then it's even hard. You're making your life harder whenever you're trying to find people. Uh, but it's I think it's important that you stick to your values. And for example, I prefer having a very solidified team that is able to work together perfectly rather than having, I don't know, the geniuses that yeah, they can take very impressive ideas, but they're completely unable to work in a team, and they have to put in their corner and doing this. It
Okay,
has
super
happened
interesting.
to us. So yeah.
That's
So
super interesting to think about the hires if they would be a good fit by being implemented into the team rather than what is
absolutely,
their own skill set. Okay, love
of
that.
course. Yeah.
Okay, let's talk about the future. Where do you see Pangea in 5 years from now?
In 5 years, okay. So in 5 years, for sure, Pangea will have products into space, and we'll be there developing even more propulsion solutions for the future of first European space exploration, but later on, of course, our ambition is to become a global player. I would say being the preferred propulsion partner for everything that has to go to space, move into space, and come back from space.
That's a big goal, but I
Yeah.
love that. Right now, Europe is in the middle of building the next generation of European launchers, right? We have the ESA Launcher Challenge. And I'm very curious to hear your thoughts on what do you think, what is the Pangea's role in this technology and marketplace? Where do you see yourself?
So uh, we are seeing ourselves as a transversal player. We want to be the propulsion provider for the next generation of
Yeah,
European launchers. So as simple and as ambitious as it might sound, but it's like in this case, institutions, all the member states, we are doing the engines, concentrate on making the rest. And we want to tackle that challenge and becoming uh, many times I say, but we want to become this Rolls Royce of space. The same that
I
is
love
Rolls
it.
Royce is doing for the aeronautical sector.
Mm,
We are seeing already quite a lot of things saying that the industry is maturing. There will be consolidation. We want to do that critical building block for all to go up and do our stuff in space.
awesome. A huge ambition, but I think you will get there. So thanks for sharing your thoughts here. Okay, before we
Thanks.
get into the last section, which is fire round questions, I want to ask you a very open question. Is there anything that you learned over your journey that you would love to share with people that are thinking about starting a company in this industry, either in Europe or anywhere on the planet? Is there anything that you would love to say to them?
Focus on what the problem you're solving with the new innovation that you are thinking to launch. Talk to the people that are having this issue, and talk to people that has been involved in the space sector as well. And in our case, we had a top-notch advisory board from day one that I actually convinced to be part of the journey. And I could call them and say, "Hey, I have a very shitty day because A, B, C. I've been said no, no, no on this. What happened in this case early on in the story, in the history of space, and is Ariane 5 or Ariane 4, to learn actually from history? I mean, for me, history is just a very good repository of experience, and that you have to have it. So I would say go talk to the people that has done it in the space ecosystem. And at some point it's about being naive as well. And if you think that more or less you have something, jump into the pool, as I said in the beginning, even though it has very shallow waters.
Awesome.
It
Thanks
will,
for sharing that.
yeah.
Good thoughts. Okay, the last section, quick fire round questions. So how does it work? I will ask you a question, and if you can answer with one or two sentences, that will be amazing. So very curious, what do you think here? What do
Okay.
you think is the current status of the European space ecosystem?
Rapidly changing due to the geopolitical situation. And it's now the time to demonstrate that we can work together. For me, collaboration is key
Unity. Yeah.
here,
Mm,
and unity.
awesome.
But
Super. Next one. Your advisory board, as you mentioned a few minutes ago, you built around that time includes former ESA Ariane leaders. How did you convince such players to join you?
Because I was first super insistent, I have to say. So at some point, it's like, hey,
Proactive.
pick my phone, answer my emails. I just want 15 minutes of your time. And yeah, early on is it was first on the technology that we're developing. The majority of them had more or less a knowledge of aerospikes and in propulsion in general. And they said, hey, I'm just want some time of you during the year and the ability to just call you and share thoughts. And then they had nothing to do. So they actually willingly said yes to be involved in the project and actually use their name and faces for that. So I'm pretty proud of that. And I'm having a very good relationship with all of them and actually pretty almost as a monthly basis. Yeah.
I love the approach. Go, go, go,
Yeah.
proactive.
Yeah.
Okay, okay. 2 more questions. What is the biggest personal sacrifice to build Pangea Space?
Of course, long hours. So I think in my case, my personal life, my family, my wife and my daughter that are suffering a little bit from that. But yeah, it's a toll that you pay. But then and that you share with your friends and family. Yeah, I would say this time, quality time with your beloved ones.
Okay, awesome. Last one. What is something that everyone gets wrong about AeroSpike engines?
Ooh, ooh. I can do, I think, a full hour on this. Mm, yeah, I would say, yeah. Many people, the first times investor calls on our spikes, they thought that it was something almost sci-fi. So that it didn't exist, something like
Mm,
holy. So you have to say, no, this is a reality. And whenever they come to our offices, like, hey, here, you have an AeroSpike, touch it, look for that. And then when you go more into the technical details, they got wrong the principle of work. But of course, this is something that we are actually creating a lot of literature for that because there is none. So you have to create it on your own. I would say, yeah, the work principle and it is a reality, not sci-fi.
and you made it a reality. So
Yeah,
let's hope that your launch goes very well later this year.
yeah,
I'm holding the hands and cross
absolutely.
fingers. Super. Thanks so much for sharing your journey. That has been actually super, super interesting. Interesting answers, interesting ways of thinking, which I think are very helpful for new players in the industry. Is there anything last you'd love to share with the audience?
Space is critical for everything, and that we should look forward on working together for going beyond. Going to the moon, to Mars, etc. But it's just through collaboration, not through wars and fights that we'll get there, for sure.
Thanks for sharing, and thanks
Yeah.
so much for being here and sharing the story.